friends, I am Dr. Santosh Desai and I welcome you all to my YouTube channel. So in the today's session, I am going to discuss how to find Laplace transformation of derivative of a given function. So suppose you have given one function f of t and you have to find out the Laplace transformation of d by dt of f of t or d2 by dt square of f of t in this way. So we have rules to find out the Laplace transformation of derivatives of f of t. So first we will see the rules one by one and then we will simplify these three examples. So let us consider the rules first. So if Laplace transformation of f of t is equal to f bar s, then first Laplace transformation of f dash t, that is first derivative of f of t and its Laplace transformation. So it is given by, it is s into Laplace transformation of f of t minus f of 0. So if you find these two values and substitute in this formula, you will get the Laplace transformation of f dash t. So here, the one of the advantage of this to use this formula is without finding the derivative, you can obtain the Laplace transformation of that function. So here you have to find out f of 0. So in the given function, put t is equal to 0, you will get f of 0. Find the Laplace of given function. Substitute in this formula, you will get the Laplace transformation of f dash t. So similarly, second one, Laplace transformation of f double dash of t is equal to, this is s square into Laplace transformation of f of t minus s into f of 0 minus f dash 0. So this is the formula to find out Laplace transformation of second order derivative of given function f of t. So again here we need three terms, Laplace of f of t, f of 0 and f dash 0. So f of 0 we know, to calculate the f dash 0 from the given function, first you calculate the f dash t. That is why you find out the derivative first and put t is equal to 0, so you will get the value of f dash 0. And one more, Laplace transformation of f triple dash of t is equal to, this is s cube into Laplace transformation of f of t minus s square into f of 0 minus s into f dash 0 minus f double dash of 0. So find out all the values involved in this formula, substitute, and then you will get the Laplace transformation of f triple dash t. So these are the particular cases, that is the first order derivative, second order derivative and third order derivative. So Laplace of these derivatives. So what is about in general formula? So if you observe these three formulae, then one can write the in general formula. So in general, nth derivative, so Laplace transformation of nth derivative of f of t is equal to. Now you check the first term. So in the three formulas, the first term is s into Laplace of f of t, s square, s cube, Laplace of f of t. Now whatever the order, you have to take that power of s. So here second order, therefore s square, first order, therefore s, third order, therefore it is s cube, and everywhere there is a Laplace of f of t. So the first term will be s raised to n into Laplace of f of t. So this is your first term. Now you check the remaining terms. So in the remaining terms, all the signs are negative. So negative, 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 and all the signs are negative. Now if you check the powers of s, you observe that the powers of s are decreasing. So here s square is there, s is there, then s raised to 0. Here s cube is there, s square, s, and s raised to 0. So powers of s is decreases by 1. and here f of 0, and you have to start from f of 0, f dash 0 and f double dash of 0. So in this way, so you will get, then you decrease the power of s by 1, so it is s raised to n minus 1 and start from f of 0. Next term is s raised to n minus 1, you write s raised to n minus 2 into f dash 0. Next term is minus s raised to n minus 2 f double dash of 0 minus and so on, and check the last term. So to check the last term, let us consider the second and third. So here the f dash 0, here f double dash 0. Now you check the derivative of the given function. So whenever there is a second order derivative, you have to take f dash 0. Whenever there is a third order derivative, it is f double dash 0. So you have to take one less. So here n the derivative is there. So that means here we need n the f raised to n minus 1 at 0. So n minus 1 the derivative at 0. So in this way you can write the general formula. So in the last article, there is one article that is an application of Laplace transformation to solve the linear differential equation with constant coefficients. And in that article, we require these three formulas. So these three formulas are very important for that article, that is application of Laplace transformation. Now let us see the examples. So let us take the first one. Now here, in all these three examples, you have to calculate the Laplace transformation of f dash. So only we have to use this first formula. Laplace of f dash t is equal to s into Laplace of f of t minus f of 0. So let us find Laplace of f dash t for the first one. So here given that f of t is equal, so this is the given function. Its value is equal to t in the interval 0 less than equal to t less than 3, and this is equal to 6 when t is greater than 3. Now we know this formula. So we have Laplace transformation of f dash t is equal to s into Laplace of f of t minus f of 0. Now this is equation number 1. Now just our aim is to calculate the value of Laplace of f of t and f of 0. Now first we calculate Laplace of f of t. Now here the function is given in the two parts. So that means you have to use the definition of Laplace transformation to find out the Laplace of this given function f of t. So next, to find Laplace of f of t. So by definition, we get, so Laplace transformation of f of t is equal to, so first we write the definition. This is integration 0 to infinity e raised to minus st f of t dt. But here the limits are 0 to infinity, but in the given example, the limits are 0 to 3 and 3 onwards. So you have to split this integral into two parts. So this is equal to integration 0 to 3 e raised to minus st f of t dt plus 3 to infinity e raised to minus st f of t dt. So you get this one. Now substituting the values, this is equal to integration 0 to 3 e raised to minus st, and the value of f of t is in the interval 0 to 3, it is t dt, plus integration 3 to infinity e raised to minus st, and the value is 6 into dt. Now simplify this by using UP rule, and this is very straightforward. So simplifying the integrals, we get now to simplify this integral, we know the rule, that is integration by parts, or you say it is a UP rule. So integration of up dx is equal to, first you write u as it is and then take the integration of p. So I denote it by p1. Again you have the two function. So next you keep alternate u plus minus sign, then minus. Now from these two functions take the derivative of this first. So I denote it by u dash, and integration of second I denote it by p2. Next sign is plus, then u double dash p3 minus, and so on. So to apply in this way, there is a one condition on u. So this u must be algebraic and algebraic with positive integers power. So if u is algebraic and also the powers are positive integers, then you can write the integration in this way. So here you can check this t, we can take it as a u, and let us take this as a p. So it is algebraic, so the power is positive integer. So by using this rule, we get it. So this is equal to. So first we write u, that is u as it is, and integration of e raised to minus st. So here we get e raised to minus st divided by minus s. Next sign is minus. Again you have the two terms, derivative of first, that is 1, and integration of second, you will get e raised to minus st divided by s square. Next sign is plus, and derivative of 1, that is 0. So the limits completes and limits are 0 to 3, plus 6 into this integration of e raised to minus st. So here you get this is e raised to minus st divided by minus s. Limits 3 to infinity. Now this is equal. Now let us put upper limit and lower limit. So let us put first t is equal to 3. So we get minus 3 e raised to minus 3s divided by s. Then this minus. Here you will get e raised to minus 3s divided by s square. So this is the value of upper limit. Minus for the lower limit. So the first term will be 0. So when you put t is equal to 0, this first term will be 0. So you get 0 minus 1 divided by x square. So this is the value of this first term. Now let us consider for the second one, plus 6 into bracket. So when you put t is equal to infinity and e raised to minus infinity will be 0 or tends to 0, then minus and put t is equal to 3. So you will get e raised to minus 3s divided by minus s. Now simplifying this, we get. So this is equal to minus 3 e raised to minus 3s divided by s minus e raised to minus 3s divided by s square. This minus becomes plus. It is 1 upon s square plus 6 and minus plus. So this is 6 e raised to minus 3s divided by x, and this is equal to. Now you just simplify the terms. Here minus 3 and here plus 6. So we get 3 e raised to minus 3s divided by s. Then next is minus e raised to minus 3s upon s square and plus 1 upon s square. So here we get the value of Laplace transformation of f of t. Now next we need the value of f of 0. So from the given function you have to, so this is the interval which contains the value 0, and you put 0 in the corresponding value of the function. So f of 0 will be 0. Again from the given function, and from given function, f of 0 is equal to 0. So let us put these two values in equation 1. So therefore by 1, therefore by 1 Laplace transformation of f dash t is equal to s into Laplace of f of t. So this is the Laplace of f of t. 3 e raised to minus 3s divided by s minus e raised to minus 3s divided by s square plus 1 upon s square, and minus f of 0 is 0. So just multiply this bracket by s, and that is the final answer. So this is equal to 3 e raised to minus 3s minus e raised to minus 3s divided by s plus 1 upon s. So here we get the Laplace transformation of f dash t, where f of t is equal to this one. Okay. Now, similarly, let us consider the second one. So f of t is equal to sine square t. So again, for the second, given that f of t is equal to sine square t. This is given function. Again, we need to find Laplace of f dash t. So you write the formula first. So we have Laplace transformation of f dash t is equal to this is s into Laplace of f of t minus f of 0. Now this is equation number 1. Now first find Laplace of f of t. F of t is given, and f of 0, obviously you put t is equal to 0, so sine square 0, and that value will be 0. So this value is 0. So you just find out Laplace of f of t and multiply it by s. So now to find Laplace of f of t. So let us consider Laplace of f of t is equal to, this is Laplace transformation of, now f of t is nothing but sine square t, and here you have to use the formula for sine square t, and sine square t is equal to, so this is equal to Laplace transformation of 1 minus cos 2t divided by 2, since sine square theta is equal to 1 minus cos 2 theta divided by 2. This is one of the standard formulas. Now use the linearity property. So we get this is 1 by 2. Let us take it outside, and by using linearity property we get this is Laplace of 1 minus Laplace of cos 2t. This is equal. Now next, put the value of Laplace of 1 and Laplace of cos 2t. So this 1 by 2, Laplace of 1, this is 1 upon s, minus Laplace of cos 2t, this is s divided by s square plus 4, s divided by s square plus 4. You will get this value. And once you get this, then substitute these values in equation 1. Also we need one more, that is f of 0. So obviously it is 0, and f of 0 is equal to sine square 0, that is equal to 0. So therefore by 1 we get Laplace transformation of f dash t is equal to, so Laplace of f dash t is equal to, this is s into, we just put the value of Laplace, so it is 1 by 2 into 1 by s minus, here you will get s divided by s square plus 4. Now just try to simplify this, so keep this 1 by 2 as it is and take s inside the bracket. So if you take it inside the bracket, here you will get this is 1 minus, it becomes s square divided by s square plus 4. And simplifying this, we get the required answer. So this is equal to 1 by 2. Now just you multiply, so you will get s square plus 4 minus s square divided by s square plus 4, and this is equal to s square gets cancelled, you remains with 4 divided by 2, 2 divided by s square plus 4. So the Laplace transformation of sin square t is nothing but 2 divided by s square plus 4. And finally, for this one, to find Laplace of f dash t with f of t is equal to sin t upon t. So let us consider, given that f of t is equal to sin t divided by t. This is a given function, and we have Laplace transformation of f dash t is equal to s into Laplace of f of t minus f of 0. Well, this is equation 1. Now try to find out Laplace of f of t and value of f of 0. So here, first we find Laplace of f of t. Now, Laplace transformation of f of t is equal to Laplace transformation of sin t divided by t. This is equal to. Now, here, division by t is there. So, whenever there is a division by t, you have to take the integration from s to infinity. So, it is integration s to infinity. But integration of what? Integration of Laplace of numerator. So, it is Laplace of sin t. And Laplace transformation is a function of s. So, therefore, integrate with respect to s. You just put the values. This is equal to integration s to infinity. Its value is 1 upon s square plus 1 into ts. Now you take the integration. This is equal to. Now 1 upon s square plus 1 is nothing but tan inverse s. Limits are s to infinity. Reason is because integration of 1 upon x square plus a square dx is equal to 1 upon a tan inverse of x upon t. So this is the reason. So you will get the value tan inverse of s. Substitute upper limit, you will get pi by 2 minus lower limit, term remains same, and this is equal to cot inverse s. So you will get the value of Laplace of f of t. Now here this is the important one, to find out the value of f of 0. So if you to find out the value of f of 0, if you put t is equal to 0, you are getting 0 upon 0. So in such a case, you rewrite f of 0 as f of 0 is equal to limit t tends to 0 f of t. So this is nothing but your f of 0. Now you substitute the value of f of t. So here f of t is equal to limit t tends to 0 sin t divided by t. This is equal to. Now when t tends to 0, sin 0 will be 0, denominator is also 0. So this is 0 divided by 0 form. And if this is 0 by 0 form, then you can apply the L'Hospital rule. Now whenever you are getting 0 upon 0 form, take the derivative of numerator separately and derivative of denominator separately. So this is limit t tends to 0. Here you will get cos t divided by 1. This is by L'Hospital rule. And now t tends to 0, you will get 1. So substitute this value of f of 0, Laplace of f of t in 1. So therefore, by 1, Laplace transformation of f dash t is equal to s into the value of Laplace of f of t, that is cot inverse s, and minus f of 0 is 1. So this is the required answer, that is required Laplace transformation of f dash t. So these are some examples on Laplace transformations of derivatives of f of t. So you remember the formulas which we need in the to solve the linear differential equation by using transform method. So with this session, with these examples, I conclude this session here. In the next part, we will see how to find out the Laplace transformations of integrals. So just we have seen the derivatives. So in the next part, we will see how to find out the Laplace transformations of integrals. For more videos, please subscribe my YouTube channel, and thank you so much for watching.